I'd like to thank Steve and Sages for allowing me to talk. This is a fabulous conference for you guys to attend. I have a fellowship at Methodist, and if it were up to me, not only would all my fellows have to take this course, but all the surgeons who use the OR would. I constantly advise my nurses when the surgeon comes up and beats on them because the system's not working to just tell them Dr. Reardon says, you don't know how to use the equipment, don't use it. But they never take that advice because it's probably not the best thing to tell an angry surgeon. But you guys, by coming to this course, should be able to walk away and troubleshoot your own systems, and then you're independent. If you leave this course and it won't go, then you probably need to call your rep. Steve paused when he was talking about where I'm from. I work at the Methodist Hospital in the Texas Medical Center in Houston, and because of our wild and wacky politics, I also have an appointment in the Department of Surgery and the Department of Cardiothoracic and Vascular Surgery with our neighbors next door at the University of Texas Medical School. We view everything that we see in the world through our eyes, at least we currently do. This past week there was a news article that Sony's going to beam transmissions into your head. They don't have that system working yet, but they've got a patent on it. Our eyes are sensitive to light, so the images that we're going to see in our system will usually start with light. I put usually because we use laparoscopic ultrasounds in our OR, in which case there's an image which started as sound and got converted to light, but in general you'll be using light. So this is a diagram that I made. There's no light cord coming in, but there does need to be a light source for your camera, but since I had to draw this myself, I left it out. It was easy. Just pretend this is one of the new modern scopes where the light travels up the same part of the handle of the cord there that the data goes through. But as Steve already mentioned, light goes out the end of your scope, strikes the target and bounces back, and it has to hit some sort of chip. And then you got to have a light processor, and usually that's in a box form, and some of them it's actually out in the camera, but it doesn't matter. That light has to be processed off the chips and then go into a camera box, which to me that's for distributing the image. So it's been processed in some fashion, and the camera box is what will distribute your image. And then the simplest system that you can make an operation with is to have a camera hooked to the distribution system, hooked to a monitor. That's the simplest system. But if you're like me, you're not going to want to have just a simple system. We have recording devices in our system, and that can be something to record a moving or a video image or something to record a still image. And we have printers, because a printer in my mind is just a device for recording still images, only it's going to take that still image and make it onto a piece of paper, and I can punch holes into it and stick it onto the patient's chart so that we can record that image and then display it immediately in the patient's chart when that's helpful. But it all boils down to all these systems have video in and video out, and my talk is about how to follow the connection and make sure you get all that right. Now, I believe that's probably true that for most people they have analog systems in their OR, not digital. And I want to talk to you just a little bit about analog. There's composite analog, there's S-video or YC, it stands for red, green, and blue, and component. And component and RGB they're both component systems. That is, the light's been broken down and it's transmitted in its components. What you need to understand about video signals in all these systems is that the human eye is extremely sensitive in the black and white part of the spectrum. We can really see details in black and white. Anybody who's ever looked at an Ansel Adams print, these are fabulous pieces of art to look at, but they're black and white. One of the reasons they're so attractive is because our eyes can perceive very minute details in that black and white image. We're much less sensitive to color details. I didn't say color. We're very sensitive to color, but we're not very good with details in the color portion of the spectrum. Video is captured in two components: the luminance data, which is the black and white portion of the image, and the chroma data, which is the color portion. So a color image first has to have the luminance data, and then it's painted on with the chroma image of the data. And I'm just a simple country boy from Texas, and here's how I think about this. These images are like a black and white coloring book. So the luminance data is painted down, and it puts a bunch of fine lines, and then you have to color that in. And all these various component systems, RGB, component, composite, whether you're using digital or new or old, how many lines of resolution, A lot of that has to do with how well the coloring goes on your black and white image. Do they stay inside the lines? Are the colors accurate? Now, when they built all these systems, remember that someone didn't say, I want a television system, and it doesn't matter what it costs, you guys make it. Engineers had to contend with cost. And so that means they have to think about what the components of the system actually cost, and then they need to think about transmitting the image, because we always transmit them in the OR generally by wires. And keep in mind that one wire is cheaper than 2 wires is cheaper than 3 wires. So that was all taken into account when they developed video systems. To save on both money and the number of wires that you need, whenever they can, and they need to compress these images, first you preserve your luminance or black and white data, because that's where all your details are, and you try to throw out chroma data to make it all fit. So in general, you want to preserve your luminance data and throw out the color data when it comes to achieving detail, because we don't see detail very good in the color spectrum anyway. Remember, your system captured an image in 2 pieces, the luminance and the chroma, and those can be put together later to describe your image, but when they're done, they have to be transmitted down a wire, and you can have 1 or more, but when they get to the display, in general, they're split up again, because the display is looking for luminance data and chroma data to make a picture. So we've already talked about the 4 ways that we can transmit analog. Remember that in general, if you combine signals, you get errors and data loss, and when you split them up on the other end, you get error and data loss. And if you stick 2 signals on the same piece of wire, and they travel down that same wire, then you can have crosstalk or interference, and that'll also degrade your image. So composite, it's the lowest resolution. It'll fill 270 horizontal scan lines. The luminance and chroma data are immediately combined, and they're stuck on 1 wire, and then at the far end, they're split. So based on what I just told you, you can expect that these images are highly subject to being degraded, because they've got all the components that I told you break down your image. And a good example is if you've got a composite system in your OR, put the color bar up and look at it. There's a lot of dot crawl, that is on the edge of the different colors. It looks like ants are marching up and down the edges of the bar. You see little dots crawling, and the colors bleed into each other. They look like it was wet paint or wet ink. They blend together on their edges. And this is just a picture of the various connections. This is the guy that everybody should be familiar with. This is how your cable TV is generally hooked up. That's the male, and that's the female on coax, 75 ohm. Then our ORs generally have, for their composite connections, B and C connectors. That's the male end, and that's the female end. B and C stands variously for a British naval connector, bayonet naval connector, and it does turn out that B and N are the first initials of the 2 guys who developed that system. At the end of World War II, the Navy wanted a water-resistant, secure way to hook wires up, and that's it. This one everybody should be familiar with. If you've got a stereo system, that's an RCA connector. The RCA in RCA stands for Radio Corporation of America, and that's a male plug, that's a female plug. This blurry plug over here is a female YC connector, which leads me into the next kind of analog signal, which is S-video, which stands for super video, or YC. Better resolution, 400 lines. The luminance data and the chroma data remain on different wires. They're separated, they each travel down their own wire, but there's 2 color signals, and they travel down 1 wire, so now you're mixing still your color signals, so there is some degradation of the image. And this is a male connector, and this is a female. Unfortunately, it's all blurry. I just put this up there. If you've ever looked at all these plugs, they got a lot of pins on them. Like our RCA connector's got a bunch of pins. But there's always a schematic somewhere that'll tell you what each plug does, and it turns out they're pretty simple. You can see that the top plug there carries the color information. That carries the luminance information, and they both have a ground. So while it might look complex, it's pretty simple. Then you have RGB, or component. They're both components. They split it up. Higher resolution. Your luminance and your chroma signals remain separated, and they travel down their own wires. And you can have 2 wires, or 3 wires, or 4 wires, and still carry a component signal. There's much higher resolution, a lot less dot crawl. We have this in ROR, and you can flip between composite S-video and RGB and watch the color bars straighten up and get more and more distinct, and the dot crawl goes away. So if you have that kind of system, that's the first time you'll probably have the opportunity to compare them side by side, and it does make a big difference. This is the highest quality analog signal. Whenever you can, if you have an analog system, that's the way you'd like to transmit all your data. We have an ROR, an integrated operating room, an OR1. It's a digital all the way. So digital information describes the picture, and as Steve told you, it's converted from an analog signal into a digital or binary signal. Did anybody get the binary geeky joke? Because I confess that the first time I read it, I thought it was a typo, but you know, 1 and 0 in binary describes the number 2. So there's really only 2 kinds of people in the world. So if you're not geeky, now you understand the joke. Once you have it in digital form, it's 1s and 0s. So as long as the signal gets to the other end, you should have all your data that's intact. Some of the more complex systems do have things to look for errors and correct errors, but in general, as long as the signal gets to the other end of the wire, your 1s and 0s show up, and those 1s and 0s describe the image. So a single wire can still transmit a high-resolution image. And we have both SDI in our operating room, which stands for Serial Digital Interface, and DVI, which is Digital Video Interface. SDI is nice because you can make really long runs with the wire. The DVI connections we have, that's the same thing that's on my Apple Macintosh computer. High definition is coming. The 2 common flavors of the 1080i and the 720p. I is interlaced. That works like your TV. It draws half of each frame, and then they're both displayed faster than your eye can distinguish, and it makes a single image in your eyeball for each frame. And then there's progressive scan, with what your TV does. I mean, your computer monitor. It starts at the top and paints each line individually from top to bottom. My house, I have a great big high-definition TV, and I love it. That they are subject to digital artifact. If you've never seen digital artifact and someone doesn't point it out, you might not notice it. Once you do, you might be cognizant and take some of the fun out of it. If you see a sports game, for instance, and the camera pans by the crowd, watch the crowd. The image doesn't stay high resolution. It sort of breaks up and looks a little pixely. That's one of the problems that you have with digital high-definition images. Nevertheless, I don't watch sports on regular definition. I always watch it on high definition. The only thing I can think of that's equivalent in life to learning about digital artifacts is when I took a wine tasting course. Prior to that, I was happy drinking inexpensive wines, and once I learned the difference between a good wine and a bad wine, unfortunately, all the good wines are expensive, and the same is true for all the video systems. The better the video system, the better it tastes, the more expensive it is. So, this is the most simple system you can have. In my OR, we're going digital, digital, digital. I like to have a lot of other stuff. I teach, I have a fellowship, we make educational videos. So we need to have some sort of recording device, and then not for me so much, but a lot of the surgeons, they want to have a printer, so we've got that too. So how do we hook this up? Well, for the recording device, it just depends on what it is. I used to have, prior to our OR becoming an integrated suite, for a long time I had a high 8 video recorder. And I had something to convert that into digital on my computer in the office. And so a line came out from the camera box and then also went from the recording device to the monitor so that I could know that I was actually recording on the device. Anytime you ever record 2 hours of black tape because you never monitored what was going on in your recording device, it's a painful lesson. I've done it, and I don't make that mistake anymore. And then we had a printer, and that printer was in the chain so we could deliver an image to the printer. Now, in my old system, the image went into the printer from the high 8, but we need to monitor it. And so we had a line out from the printer because the printer had its own memory, and it would store 4 images or 6 or 8, whatever you told it, line, so that the camera box went straight to my printer. That way I didn't have to worry that somebody watched the image and changed the color settings on the recorder because they liked a brighter red picture, and it might degrade my whole system. In the more modern systems, they have pass-throughs, and you don't have to worry about that. There's a problem, though, because we got multiple inputs. We've already talked about all these different ways that you can input a device. And in general, I'm talking about downstream from your camera box now. And the problem is, whenever you have a device with multiple inputs, there has to be something on the front of the box that tells it what input that device should be recording or monitoring. And you need to look on the front, because they almost all have something that's called an input select. And you need to make sure that that button is set to match the input you want the device to have. I've recorded 2 hours of black with that mistake too. Whenever you have multiple users in your OR, and we do, it gets to be a problem because multiple users get to get after your systems, and the problem with surgeons is that surgeons have absolutely no qualms about pushing buttons. They'll push one, they'll push them all. Doesn't matter what the buttons do, they don't care. So we've had systems where all the buttons got pushed. Turns out the power button wasn't on one component, sort of a critical button. But now by the time they got through pushing the buttons, now they don't remember what those buttons were set to originally. You turn the power on, you still got no image. So we used a serial setup. It wasn't my favorite, but since other people came behind me, we used a serial setup. The advantage of that is that whenever you have a setup like this, when somebody comes along and blindly punches buttons and messes up the settings on one of the devices, you either get a bad image or no image on your monitor, and this clues you in that something in your chain is not set right. And I did it because I got tired of recording black video for 2 hours, right? And it's only going to happen when you have a once-in-a-lifetime operation like where an alien jumps out of a cyst and somebody has played with the buttons and you recorded black. What my OR looks like now. It's different because now I use a DV cam, which is, it will record onto both the tiny little DV cassettes that you probably use in your home recorder, or what I use, a DV cam tape, which is a broader tape, puts more data down. And we have a DVD CD recorder, and you can record either still or motion on that, and we have a printer. And because I have an integrated suite, we now have something that will send my image out of the room. If you want to go out of the room, you do have some options. You got ISDN, a T1 line, IP, that means the internet. You want to do this, and you want to send the image out of the room. Both parties have to have some device to compress and decompress the video. You've probably heard people talk about codecs. A codec, that's short for compression decompression, and it's a box. You can buy these boxes for $2,500 to $5,000 new. My rep locally told me that you can buy them on eBay for cheaper. You need to probably have encryption because of HIPAA. You don't want to be sending Miss Smith's picture across wires that someone else might intercept or look at unless it's been encrypted. And the boxes have to be compatible. That doesn't mean it has to be the same manufacturer. That you do need to be able to do the same codec and the same encryption system. You got to pay $49 to $79 a month. Just depends on where you are. It's 20 cents to 40 cents a minute per line, and there's 8 lines in the ISDN. And if you want to go long distance, that is not in your local community, then it's 14 cents per minute per line for the long distance charge. There's 8 of those too, so it costs about $4 a minute to broadcast. But the quality's good, and it's very reliable. That ISDN line, you can think of it as a line from your building into the central exchange of the phone company, and there's not a lot of changes in the route, and as long as everybody's on that system, you should get good quality and should be very reliable. A T1 is even cooler. This is a bundle of cables. I think there's 24 lines in a T1. Much more expensive. If you look, Southwestern Bell, all the various companies you can find, they're all going to advertise. They'll sell you a T1 for somewhere around $500 a month is what you'll usually see on the websites. You can get them for cheaper than that if you simply call around, do your shopping like you can anything else on the internet, and then call the company and say, you know, Company B offered me my line at cheaper than yours, and they will bargain down, but it's still going to be $3,000 a year at the best. But again, you've got your own connection of fibers from your building into an exchange, then across a backbone to somebody else, as long as they've got a T1, very good quality and very high reliability. TCP/IP, which is the internet, most of your buildings probably have that, which makes it very inexpensive. It's already in there and you're using it, it's free. The downside is that the reliability is lower, and you know on the internet, the signal gets shifted wherever there's capacity to handle it, and so there may be pass-offs if there's a problem in the system, and you may lose your signal, so the reliability is lower, and so is the quality. But in summary, like Steve said, you just need to be able to follow the flow. And once you can do that, it's a lot less scary to look at the back of these boxes. Remember, starting at the source, all video flows from a video out to a video in. So once you start with your camera box, if you plug something into a video out, it needs to go to a video in. And usually your final destination would be a monitor of some type. Even if you're just recording for later use, you should monitor what you're recording, and you may not actually be recording. And you want to use the highest resolution signal over the shortest distance, i.e. through the fewest devices, in order to get the best image. And remember that with all these devices having all these inputs in the back, that you need to select on the front the input that you're using, and you should choose the highest quality input that you can. This is a picture of the back of one of the boxes in our cardiothoracic operating room. My integrated suite, it's too complex even for me, but this is what our cardiothoracic guys are using to harvest vein out of the leg. Now, if you look at that, there's a lot of stuff here. That's a composite signal there. That device there is a control bus. That's how the devices talk to each other, and one can control the other, and I can control everything from the camera head in the field. There's S-video, there's SDI. There's just a ton of cables back here. And this is our DVD CD recorder. You can look down here. This is actually a touchscreen that slides out in the front. Remember that these DVD devices, it's a CPU, it's a computer. It does have a drive in it. It's got a DVD in it. This is transmitting, this is a DVI, a real short connection, so that's a DVI connection to the monitor. But this one has composite, component, RGB, SDI, DVI on the back. These color jobs over here, they look kind of like S-video, but don't push your wire in there real hard. That's actually for a keyboard. It's a serial connection. It looks a lot like a S-video connection, but it's pretty complex unless you understand to follow the flow. And to show you, here's where it would finally end up. And what they've got is line A has got an S-video connection. Then they have down here a component connection. They've got RGB, and that last slide I showed you, the RGB was really hard to see. It's one of the wide bricks like your computer puts out. But up here, we've got green, red, and blue channels and a sync on black right there. Here's a whole bunch of other component input. So there's a lot of choices that you better set right on the front of that monitor. Now, in my OR, we don't have big monitors like this anymore. In fact, it's my understanding, and maybe the reps can correct me, they're not going to make these monitors anymore. You are going to be using a flat panel display sooner or later. Now, these guys really don't break. For training my fellows, I have in my office one of the original Sonys that the hospital gave me because the little connection in the back's loose, and so you only get a picture if you put a piece of tape and tape it over, but it was free, but they really don't break. But if you're going to do complex advanced laparoscopic surgery, then you really need to move to a digital monitor, and you want to try to have the highest resolution you can because it does make a difference. But in my OR, we're digital here, and digital here because I want to have the highest resolution I can have. And it's all simple, though. Video comes out there, video goes in there, and it's SDI, it's digital. But this is not what's on my tower, my boom hanging from the ceiling. There's a lot of stuff, and all those boxes have all those connections in the back. It gets pretty hairy back there, but it all boils down to the same thing. Video out comes out of my camera box and goes to video in on that DV cam. And in this case, it's Firewire. It's IEE 1394. That's nice because not only does that wire carry a digital image, but it carries control signals. So I turn my recorder on and off from the operative field with the handle of the camera. So I'm kind of fond of things that'll carry both a control signal and a nice digital image because it lets me control the device from the field. And then a video out comes out of my DV cam and goes into the monitor. Unfortunately, my DV cam has an S video out, so I don't monitor that during the operation. When I'm recording, we start the tape. I switch over to my S video input to the monitor and look and say, yep, there's the image. I'm not recording black. And then we go back to my nice digital input on the monitor. But I've got a DVD recorder. There's a video out to a video in, and it's digital. And then there's a video out on that DVD to the video in on my monitor, and it's digital. So if you want to record in DVD or you want to print an image, to print an image in our system, you store it temporarily on the DVD recorder. You need to look on your monitor and see that you really capture what you thought you wanted to capture. And then we've got a video out that goes into the recorder, and then a video out on the recorder that goes into the video in on the printer, and that's a USB cable that everybody should be familiar with. So that DVD, it's just a computer. And on our system, what you see is a set of folders. They look just exactly like folders on a laptop, and your image is one of them. And you tell that CPU, I want to print this image, and it comes out the USB cable and prints on our nice printer. And then finally, since we now have an integrated suite, we have a line that goes video out from my camera box, and it goes to video in. This is where they lose me because there's a big locked cabinet they won't let me in with all sorts of components in it. And it's probably best because, like most surgeons, I'm not afraid to push buttons. And from there, if I want to send it out, I need, at that point, help from a technician. But you can break this big complex system down. It's all a series of video outs going to video ins until you get to your destination. In my OR, that's always a high-resolution flat panel display. If you want to go distal, whatever their monitor is on the other end, that's where it's going. And that's it. Thank you. I'd be happy to answer any questions. That's in Dan's talk? Okay. In that case, the question was what kind of DVD to put in your DVD record device, because they come with all sorts of alphabet soup flavors, but Dan's going to talk about that, so I won't. Yes, sir. Doesn't matter. They're interchangeable. When someone's wire breaks, they come and borrow yours. So his question was about the wires in the back. How do you keep people from touching those? With surgeons, you can't, right? You can threaten them with death. It won't matter. They'll go in the back, and if the picture's not working, they say, oh, maybe it's a wire. And so they'll just start changing wires, okay? And some of what you see in the didactic lab should have to do with how you can tell if it's a wire problem. But what I do, and what I think that everybody who operates in the operating suite should do, is you should be required to follow the flow of electrons. So if there's a problem in the front, we check the buttons in the front first, because we know how it's supposed to be wired up. If all your buttons are set correctly, you need to stick your head around the back of the card. At that point, I usually break scrubs so that you can actually, they got a back door on these cards, and you got to open them up and look in there. You need to understand how your image, normally set up, flows from the camera box to the monitor. And then what I do is I look to see who's been messing with my wires. The difference is a lot of surgeons look back there and they see a lot of wires and they say, well, I don't know, call Biomedical. They charge $50 just to come in our OR, right? So we troubleshoot whenever we can. In fact, the nurses call me a lot to troubleshoot. What we're hoping for here is that when you guys leave, you don't ever want to call Biomedical. You should be able to understand it to the point where if you have to call for help, it's a serious problem. And like Steve said, they're probably going to come take away one of your components. You'll need to temporarily replace it. Yes, sir. So his statement was that you can color code the wires. Somebody knowledgeable comes and sets it up the first time. And we did this in our OR. There's a piece of colored tape on both the wire and then on the box right next to where that wire plugs in. And they ought to be different colors on each end so that if you can match colors, you can set it up right. I can tell you the problem in our setup is that when somebody's wire goes bad and your room's not currently in use, maybe you turn over your room, someone will come and pilfer your wire, and the one that gets replaced doesn't have color coding. But for your nurses, it's an excellent way that if you know how to set it up, you set it up correctly, you check it all, and then you put colored tape on both the connector and the hole where the connector goes, and if your nurses can match color, in general, they can troubleshoot in a very simplistic fashion in the back. I can tell you what we're going to do. We're going to take this very program here home, and the nurses are going to get to learn exactly what you're learning, and hopefully they'll acquire the knowledge to troubleshoot, which should cut down on the interaction they have to have with the surgeons, which is usually a good thing. Yes, sir. His question was, sometimes in his OR, the slave monitor picture doesn't look anywhere near as good as the one that's on the master tower. And in our OR, the reason for that is there's a BNC connector that makes the trip over. And particularly if you have old monitors, there's no way. Now, what they've done for our tower that we currently still have, for instance, in the thoracic operating room, is that there is an S-video out from the camera box, and they bought a real long S-video cable, and we now would run S-video from TV to TV. Yes, you can. We take it right out of the camera box. There's always more than one output, and would run an S-video cable to the slave in those rooms that have a tower. But I avoid operating in those because once you go digital, you don't want to go back. Any other questions? Thank you very much.